So on top of page 4, we have the graph of a piecewise function, f of x. And, and you know, for a piecewise function, there is different rules used in calculating the, there are different rules used in calculating the value of a function, right, for different input values of x. And so in this piecewise function, the value of the function f of x is equal to x plus 1 if x doesn't equal 2, and f of x is equal to 4 if x is equal to 2. So the graph of f of x is a straight line, right? So here's the graph of f of x. But at x equals 2, there's a hole in the line. That open circle is called a hole. And that hole is located at the point 2,3 in the coordinate plane. Can you guys see what I'm writing?
No.
Or is it on?
You might just need to turn the
Boy.
Jim 10.
Yeah, I do have a pen. I don't know why sometimes the system, why this is hard to read. Should
have a brain that's set.
all I see is really zoom. Okay. All right. Now can you see the word hole? Right. So that hole, right, the x coordinate where that hole's located is 2, and the y coordinate is 3. Okay. And so if that hole was filled in with that dot, right, then we would know that the value of the function at x equals 2 is equal to 3, right? We have f of 2 is equal to 3. But instead, over here, at x equals 2, we have f of 2 is equal to 4. Okay, that's where this closed circle is. So the closed circle is on the graph of f of x. The open circle is not. Okay. That's the graph of the piecewise function. Okay. Limits are concerned with the value of the function for values of x near a number, but not at a number. Okay. And so let's consider the table of values down below here. And let's look at the first table on the left. Okay. In the first row, right, are values of x in increasing order, right? We start at 1.9, 1.99, 1.999. In the second row are the corresponding values of the function f of x. Okay? And because these values of x don't equal 2, okay, we use the first rule up here in evaluating the value of the function at each of these values of x. So at x equals 1.9, the value of the function is 2.9. At x equals 1.999, the value of the function is 2.999. Okay? So none of those values of x equals 2, right? So we use the first rule in evaluating the value of the function at each of those values of x. Well, you'll note these values of x in this first table, right? They start at 1.9, they're increasing in value, and function, each succeeding value of x is getting closer and closer to the number 2. And the corresponding values of the function, right, are getting closer and closer to the number 3. Similarly, in the second table, we have values of x just greater than 2. So going from right to left, right, we start at 2.1, 2.01, 2.001. And you can see as we go from right to left, each succeeding value of x is getting closer to 2. And the corresponding values of the function, similarly, each succeeding, going from right to left, each succeeding value of the function is getting closer to 3. Right, it starts at 3.1, goes down to 3.00. Okay. So you can see a trend here, right? As x gets closer to 2 from the left or from the right, the value of the function is getting closer to the number 3. Even though at x equals 2, the value of the function is 4, not 3. Okay. So this pattern that we're seeing in these two tables here, right, we have fancy mathematical notation for that, and it's called limit notation. Down here at the bottom, right, we say that 3 is the limit of f of x as x approaches 2. So it would really be better if I had written f of x. We say that 3 is the limit of f of x. It just happens f of x is equal to x plus 1 when x does not equal 2. We say that 3 is the limit of f of x as x approaches 2. And we write the limit of f of x as x approaches 2, okay, that's what the arrow means, x is approaching 2. The limit of f of x as x approaches 2 is, in this case, equal to the limit of x plus 1 as x approaches 2, which is equal to 3. So that's the concept of a limit in a nutshell, okay? It tells you for values of x close to a number, say 2 in this case, the values of the function are close to the number 3. Closer x is to 2, the closer the value of the function is to 3. That's the idea, limit. It has nothing to do with the actual value of the function at x equals 2. Any questions on that? So let's learn how to calculate some limits. Okay. And we're just going to be dealing with 2 types in this class for exam 1. So in the first example, okay, we're going to find the limit of x cubed minus x plus 4. That's our function. We're going to find the limit of this function as x approaches 2. And it says we're going to find the limit by direct substitution. The first step in finding the limit of a function as x approaches some number is to plug that number in for x into the function. And if the value of the function is a real number, that's the value of the limit. Okay. So we put 2 in for x. We have 2 cubed minus 2 plus 4. And now you know you got to follow, that's arithmetic now, right? You got to follow the order of operations. Right? Exponentiation, right? Before addition and subtraction. And when you do that, you get you, I'll write it out. 2 cubed is 8, so we have 8 minus 2 plus 4, which is equal to 10. So that says the closer the value of x is to 2, the closer the value of the function is to 10. Okay? Are you with me?
So we just leave it like that?
Yes. The
The
box.
answer's okay.
You're done. Okay? You found the limit. Okay? In the next example, our function is 2x plus 7. So now we're going to find the limit of this function as x approaches minus 1. So again, the first step is to put minus 1 in for x into the function. Okay. So we have 2 times minus 1 plus 7. And now when you follow the order of operations, right, you know that arithmetic expression is equal to 5. So the closer the variable x is to minus 1, the closer the value of this function is to plus 5. Okay. Are you with me? All right, now let's do some that are not so obvious. Okay. That require, now remember the first 3 pages, right, we simplified algebraic expressions. We're going to use those, that simplification of algebraic expression in evaluating the following limits. That's why we did it. So when you do the WebAssign homework, there are 2 parts. Part A is to simplify the algebraic expression, and then part B is to use that result to evaluate the limit. Okay? All right. All right. So what's step number 1? Direct substitution, right? Put 2 in for x. And if this, once you put 2 in for x, the value is a real number, that's the value of the limit. Okay? So this down below, let's put 2 in for x, and we have 2 squared plus 2 minus 6 over 2 squared minus 5 times 2 plus 6. And now you got to do the arithmetic in the numerator and the arithmetic in the denominator, right? And so 2 squared is 4, 4 plus 2 is 6, 6 minus 6 is 0. In the denominator, 2 squared is 4, 5 times 2 is 10, 4 minus 10 is negative 6, and negative 6 plus 6 is 0. 0 divided by 0 is equal to what? Huh? Can you ever divide by 0 in mathematics? So what's 0 divided by 0? Undefined. Yeah. But when it's 0 divided by 0, the limit still may exist. Okay? So even though the function is undefined at x equals 2, the limit still may exist. And if the limit equals a real number, that is the y coordinate in the location of a hole in the graph, like the hole in the graph on the previous page. Okay. So we have to simplify this algebraic expression. Okay. And we did it on page 1. This algebraic expression reduces to x plus 3 over x minus 3. So make a note. Right? Page 1 of notes. We reduce this algebraic expression to x plus 3 over x minus 3. It's not common factors in numerator, right? So you go back to page 1 of your notes and you should be able to see that. Okay.
You did that.
Huh?
The limit was undefined.
limit's not undefined, the function's undefined.
And why didn't you use the,
Okay. So everybody should have in their notes us reducing this to x plus 3 over x minus 3 on page 1. Okay. And now you do direct substitution. Put 2 in for x, and you have 2 plus 3 over 2 minus 3, which is equal to negative 5. So the limit of this function as x approaches 2 is equal to negative 5. Even though the function, this function is undefined at x equals 2. The limit still exists. Okay. This is x approach, x is the x coordinate in a point, in a coordinate plane, right? And this is the y coordinate for a point in the plane. And there is a hole in the graph of this function here at the point 2 comma minus 5. Now you don't have to write that on the exam, I'm just explaining what we're discovering, okay? That if you had to graph this function right here, you would know there's a hole in the graph at 2 minus 5, okay? And we will be doing lots of graphing this semester. Okay. So any questions? On that, ladies and gentlemen. Okay. All right, so let's do the next one. So we're going to find the limit of this function, x squared minus x minus 6 over x cubed plus 8, as x approaches minus 2. So again, you do the direct substitution to see if the value of that function is a real number. So we have minus 2 squared minus negative 2 minus 6 all over minus 2 cubed plus 8. Again, you got to follow order of operations, right? Minus 2 squared is 4. Minus a negative is plus 2. So 4 plus 2 is 6. And 6 minus 6 is 0. Minus 2 cubed is negative 8. And negative 8 plus 8 is 0. So we got 0 over 0, which is undefined. So this function is undefined at x equals minus 2, but the limit still may exist. Okay. Well, what was it back on page 2? We reduced this quotient to x minus 3 over x squared minus 2x plus 4. So we did that on page 2 of your notes, right? Going from here to there. Right? We reduced this algebraic expression to x minus 3 over x squared minus 2x plus 4. Page 2 of your notes. You should be able to verify that. Okay. Now you put in minus 2 in for x. We have minus 2 minus 3 over minus 2 squared minus 2 times minus 2 plus 4. Well, the numerator is minus 5. And the denominator is 12. So the limit of this function as x approaches minus 2 is equal to minus 5/12. So there's the hole in the graph of this function at the point x equals minus 2 and y equals minus 5/12. Okay. This is the x coordinate. This is the y coordinate. Okay. Now you don't have to put that on exam. I'm just telling you what we discovered. Does everybody have their work from the first 3 pages? So when I say this reduces to that, we already did that. You got that in your notes, right? If you don't, then you're not going to understand where I got that. All right. Any questions on this? All right. Next, this one, right? The function, we rationalize the denominator. So, step number 1, evaluating the limit, you put 1 in for x, right? So we have 1 minus 1 over 2 minus the square root of 1 plus 3. 1 minus 1 is 0. Now the denominator, what's under the radical? 1 plus 3 is 4. Square root of 4 is 2. And 2 minus 2 is 0. So when we put 1 in for x, we get 0 divided by 0, which is undefined. Okay. So we have to simplify this function, right, by rationalizing the denominator. Right? We rationalized this denominator in class last week, right? So this is equal to, after we rationalize the denominator, we got, we wrote it 2 different ways. I'm going to write it as the negative of 2 plus the square root of x plus 3. You could have, right, you could have also written it out as minus 2 minus the square root of x plus 3. It doesn't matter. You just write the minus sign. So when we rationalized the denominator last week, right, we came up with a negative of 2 plus the square root of x plus 3. And now if you plug in 1 for x, you have the negative of 2 plus the square root of 1 plus 3. 1 plus 3 is 4, square root of 4 is 2, 2 plus 2 is 4, so this equals minus 4. And so I forgot to write on here, in going from this step to this step, right? We did that on what? Page 3 of your notes. You were taking notes last week, right? You know how we rationalize that. And so this is the kind of the WebAssign homework is, right? Part A, you do the simplification. Part B, you find the limit. Okay. Any questions on any of those on page 5 that we just did? All right, so flip over to page 6. We'll do these last 2 on page 6. You'll have everything you need to successfully complete the WebAssign homework. So now, right, h is our variable instead of x. So when we do the direct substitution, right, put in 0 in for h.
we have 5 minus 5 times 0 plus 1 squared over 0. The denominator already equals 0. And now you gotta do order of operations, right? 0 plus 1 is 1, and 1 squared is 1. We have 5 minus 5 times 1 over 0. The numerator is equal to 0. And 0 divided by 0 is undefined. So we gotta simplify that. Yes, sir.
We could just stop it after the denominator is equal to 0, right? I guess since we made that substitution.
Yeah, but there is limits where the numerator is non-zero, but we're not dealing with those. So you want to verify it's 0 over 0. Okay. All right, but almost certainly in this class, it will be. If I was a betting man, right, I certainly would bet it will end up 0 over 0. All right. So we simplified this in class, right, on page 2 of your notes, right? And this simplified to, one way to write it was minus 5 times h plus 2. Now you could have distributed the minus 5s and you had minus 5, minus 10. It doesn't matter, right? The value of the limit's going to be the same. And now you do the direct substitution, put 0 in for h. You have minus 5 times 0 plus 2, which is equal to negative 10. So this function is undefined at h equals 0, but the limit still exists. And what we know if we were graphing this function is that there would be a hole in the graph at the point 0 minus 10 and towards the plane. Any questions? But you don't have to write on the test or anything where the hole is in the graph. Just tell me that's what we're finding out here. I'm curious, how many in here have to take Calc 1? Right, so you guys who take Calc 1, you'll be up to your eyeballs in this stuff. Okay. All right. All right, so lastly, we have 1 over x minus 1/3 over x minus 3. Remember, this is a complex fraction that we simplified, on page 3 of your notes, right? It was like the last thing we did on page 3. And so if you put 3 in, remember the largest fraction bar is the main fraction bar. So if we put 3 in for x, we have 1/3 minus 1/3 over 3 minus 3. And so in the main numerator, 1/3 minus 1/3 is 0. 3 minus 3 is 0. And so 0 divided by 0 is undefined. So we got to simplify this complex fraction. And when we simplify that complex fraction, we got minus 1 over 3x. And now when you do the direct substitution for the variable x, you get minus 1 over 3 times 3, which is minus 1/9. So this function is undefined at x equals 3, but the limit still exists. And so there is a hole in the graph of this function at the point 3 minus 1/9. Okay? You think you do the WebAssign homework now? Right? Alright, so remember, most problems in web design have two parts. Part A is to simplify, and then part B is to calculate based on your simplification. Alright, so let's do a condense.